So we want to determine the number of zeros, and the answer is either going to be 0, 1, or 2. Remember, this is the number of x-intercepts. So how many different ways could a quadratic cross the x-axis? Well, it could not cross it at all. It could just barely touch it, just with one point, that would be the vertex, or maybe it crosses it twice. So our options for the number of zeros are 0, 1, or 2. Never any more than that, never any less than 0. And then we also want to know the type of zeros that there are. Well, there are real and there are imaginary. So if it actually crosses the x-axis, we will have 2 real x-intercepts. If it touches it just once, we will have 1 real x-intercept. If the graph doesn't cross the x-axis, we will have 2 imaginary solutions. 0 real solutions and 2 imaginary solutions. Okay. We've talked about using the discriminant for problems like these, but the discriminant is only useful when you're in standard form. So you could multiply this all out and put it in standard form to use the discriminant, or you can just think about what this graph is going to look like. Sketch a quick little graph of it. This is in vertex form. So remember, these two numbers are the vertex, but you switch the sign of this number. So the vertex is -3, +4. And based on this A value, it doesn't matter that it's a stretch of 7. That is a +7, which means that this graph is opening up. So if the graph looks like this, how many times does it cross the x-axis? That tells you the number of real solutions. So if it does not cross the x-axis, it has 0 real solutions, which means that it must have 2 imaginary solutions. Remember, imaginary solutions always come in conjugate pairs, so that you can't ever just have 1 imaginary solution. You will always have either 2 imaginary solutions or no imaginary solutions. So I'm going to leave you to find, this is the graph of this equation. I want you to tell me how many, 0, 1, or 2, solutions there are, and then if they are real or imaginary.